as I look at this guy, I try to look to see what method can I use. And I can't use the addition method because this is an x squared and this is an x. So essentially, even though the variables are x and y, the powers are not going to help me any. So the easiest thing for me to do is to solve for either x or y in one of them, and substitution. That's why I mean that 90% of the time you're going to use substitution on these suckers. What are we intersecting? Well, we haven't seen this guy yet, but he's coming. And this guy is something called a hyperbola. And a hyperbola would look something like this. And then you have a straight line. Now, I don't know what the straight line's going to do. It can do any number of things. It can come up. Let's see, it's going to have a negative slope, so it's actually going to come down, which means I could have two places of intersection. It could also, if I think about the hyperbola, it could also somehow come in between, miss one arm, but hit the other, which means you could have one. Or, if this is the hyperbola, the dang line could come down all the way in between and miss both arms. Could actually do that. So I could have two answers, I could have one answer, I could have no answers, but that's what I'm intersecting. I'm intersecting a hyperbola and a line. Do I necessarily care when I'm working the problem? The answer is no. I never think at all when I'm solving a system, unless I have the picture in front of me, a system of nonlinear equations that, oh, that's a hyperbola and that's a line. I just say, I've got to solve for x and substitute back in. I just solve the stupid equation. So if you take a look, if I solve, it doesn't matter who I solve for either x or y. I think I want to solve for x. And you're going to say, well, why would I choose x over y? Well, if I were to solve for y is going to be equal to 7 minus x. I'm going to have to put 7 minus x in for y and then square a binomial. Once I square the binomial, I'm going to have to whap it with a negative 1. What are the chances are that I'm going to make a mistake? Probably pretty good. If instead I were to solve for x, then I'm going to put it in here for x squared. I'm still going to have to square it because it's going to be 7 minus y, but then I'm not going to have to whap it by a minus sign. The only minus I'll see is right there. So it doesn't matter which one. One's going to be more work than the other, but I'm going to solve for x. So I'm going to have x squared minus y squared equals 21. And we said that if we're going to use the x1, that x is going to be 7 minus y. And that comes from this equation right there. And now I'm going to square it. Now, if you square something, remember it is that thing times itself. It's not 49 minus y squared. It's 7 minus y times 7 minus y. So that's going to be 49 minus 7y, and a minus 7y is a minus 14y, plus y squared minus y squared equals 21. Is that not cute? And you're going to say, why is that? The squareds drop out. It's like, yippee. So that says that 49 minus 14y equals 21. Subtract 49 from both sides. So minus 14y equals 28. Oh, isn't that convenient? And it's a negative 28. So that y is negative 28 divided by negative 14. Y is 2. Such an innocent little answer. That is so innocent. And then I know that x is 7 minus y. So if y is 2, then x is 7 minus 2. So x is 5. So I have one intersection point 5 too. So the picture I've got, since I only have one intersection point, is this one right there. The line is only going to intersect in one place. Right there, at that point.